Welcome to video number 3 on ellipses. In our last video, we learned about horizontal ellipses, and in this video, we're going to learn about vertical ellipses. So in a vertical ellipse, the major axis is actually going to be the y-axis because that axis is the longest. So we're going to write y-axis. That would make the minor axis, or the shorter axis, the x-axis. Okay, now let me write down the equations for a vertical ellipse, and this is very important. Because this is a vertical ellipse, what we're going to do with the parent function is we're going to write x squared over b squared plus y squared over a squared equals 1. And note that in the last video, in the horizontal ellipse, the a squared was under the x. Here, because we have a vertical ellipse and the y is the longer axis, the a squared is going to go under the y. So an important note is that the a squared always goes under the longest axis, okay? That's super, super important. If one were to just see an equation and you saw that the a squared was under the y squared, you would say, oh, that must be a vertical ellipse. So just make a note of that, okay? Then our standard form, you could probably guess what that is. That's going to look similar. This is going to be x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. And my center is going to be hk. All right, again, with the vertical ellipse, the a squared is going to go under the y squared. Okay, this would make our major radius lie on the major axis. So our major radius would be the letter A, but this time it's this distance here. Okay, that's A right there, this whole distance, which would make this point 0A. Because this point is on a major axis, this is going to be a vertex. Okay, so notice the vertex here is on the major axis. It just happens to be the y-axis. This distance here would be A, and this would be 0, negative A, my other vertex. Okay, which means our minor radius would be the letter B, and in this case, B is the short distance here. This is the point B0, and because this point is on the minor axis, I call this a co-vertex, kind of like a co-pilot, which means this is the distance B, this point is negative B0, also a co-vertex. Okay, so vertices, again, are going to lie on the major axis. Co-vertices are still going to lie on the minor axis. So just make a note, these are on the major axis. These are on the minor axis. Okay, and our foci, remember we said our foci are always going to be on the major axis. Okay, so in this case, they're going to be equidistant between the center, and this is going to be the point 0C, okay? And this is going to be the point 0, negative C. Same formula as before, I'll just write it down here. C is still gonna equal plus or minus the square root of a squared minus b squared. Okay, so in the next video, what I'm going to do is do some numerical examples so you can kind of see how this all works. So again, before we do the next videos of the numerical examples, make sure you've watched all of the previous videos and you have excellent notes so that you can reference the notes as we go through the next examples. Okay, so I will see you in the next video.